Hi everybody, I wanted to talk about this case. We're going to be working on the analysis and decision-making case. This is at the end of chapter 3 in your cost book. It's on page 3-52. You want to look at it, and you've got this data set which was posted for you. And they want to know, they want to predict landscaping costs, and they've given you 3 cost drivers: equipment hours, large trees, and direct labor hours, and they want you to see which one of these best predicts landscaping costs. So let's have a look. So I'm going to do a regression a number of different ways so you can sort of get the pattern. Before I do regression, I usually like to get a visual, do a little scatter plot of the data and the shape of the data. In order to do regression here under data, you need to have had the data analysis add-in installed. So that means you have to go to File and down here at the bottom. Let's see if I can put this up where you can see under Options. You want to go under Add-ins and then add in the Analysis Tool Pack and then hit OK. I've already installed it, so I'm not going to create some sort of activity there. All right, so the first thing I'm going to do is, let's see, I've got 3 cost drivers. I'll just pick equipment hours. I don't think it matters. It works the same way if you pick a different. So I'm going to insert a little scatter plot here, and let me just get a look at this. And it's looking like a round cloud to me. I really don't see any shape to the data. Perfectly linear data would start low at the right and get bigger and bigger as you have more and more units. If there is a pattern, it's very, very slight. Part of the problem could also be that this is not enough data set. 12 is not really enough data points to create anything statistically meaningful. I'm going to drag it down here and let's see what 3 years looks like. Okay, so now it does have a little bit of an upward motion. It could be that with 1 year there was just not enough variability here between 100 and 150 to really see very much, but now with the 3rd year having a lot more activity in this higher level, you can see this upward motion a little bit. There's quite a bit of noise around what might be a line that would be dropped in the middle of this data. So it's not a super tight fit, or what your book would call a goodness of fit, or other people might call a goodness of fit. But let's do the regression and see what the numbers look like. So I'm going to go under Data, I'm going to go under Data Analysis, and then I'm going to scroll down here to R Regression and open it up. So the Y range is what you're trying to predict. So we're trying to predict landscaping. Let's do all 3 years, but you can do 1 year at a time, which they do ask you to do, but to keep you from having to stare at me for long periods of time. All right, let's see here. Let's do equipment hours. I'm intentionally including the label in it, in my range, and I'm clicking here. See it? So be sure, I like the label to show up in my analysis, not just X and Y. I want it to have a name. And then for an output range, let's see here. Why don't we put it right below the graph? How does that sound? All right, let's see here. R squared is our goodness of fit, and that anything above 0.3 is starting to get interesting. Anything below 0.3 is really not very helpful. This is 33% of the variation in landscaping costs that's predicted by equipment hours, and generally sort of the rule of thumb way to interpret that. 1/3 of the data, not fantastic, but it's over the barrier for saying throw it out. The significance of the model, the predicted model, needs to be below 0.05 and as well below 0.05, which is great. And then the actual individual variable needs to be below 0.05, which this is less than 0.05 in the model. So it looks like equipment hours is informative, not overwhelmingly informative, but it is informative. So 0.3 to 0.5 would be moderate. Anything above, anything 0.6 or higher would be strong predictor. So, you know, this is helpful, but we sure would like a better one. So let's look at number of trees, shall we? And let's get all 3 years in here. You can do it 3 times. 1 year, 1 and 2 years, 1 and 3 years just to get practice, but we'll go ahead and jump right to the 3 years. So let's look at the scatter plot. I don't see any upward motion. This looks to me like a cloud. I could drop a line any one angle here, and I probably get the same distance from the line from all those plots. So I don't see anything. Let's see if regression sees it's something that I don't see. So I'm still going to keep the same landscaping costs, but for the predictor, I'm going to use number of trees. I'm going to do this 3 years. I'm jumping right to the, make sure labels is clicked here, and then I don't want it to go on top of the other one. Let's put it below the graph here. All right, let's see what we got. R squared is way below 0.3, right? So almost nothing, which is what the cloud sort of told me. The model's not significant, that's above 0.05, and the variable's not significant. So the number of large trees on the job doesn't seem to be very interesting in terms of what it costs to landscape. So that's a dud. How about direct labor hours? All right, let's graph it. See what the scatter plot looks like. Well, that upward motion looks at least as good. And you know what I haven't been doing, and I really should, is in the label here, I should put what this is. This is versus direct labor hours. And this one was landscaping versus big trees. In case I want to share this with everybody, I should do a good job documenting exactly what these were. And this was equipment hours. Okay. So it's got some noise around the line, but this does seem to have an upward motion. And so let's see what regression says about it. So data analysis, regression, same outcome variable, except for this time my income, my predictor, cost driver, I want to be direct labor hours. Let's change where it goes. So it goes below the new graph. All right, and I got labels checked. Okay, good. All right, let's have a look at this. R squared. So it's above 0.3. It's pretty close to the other one, 0.35 versus 0.33. Remember that 0.33 up here. So they're comparable. They're above the threshold, but not a ton above. The model is significant and the individual variable is significant. So it's predicting, not a strong predictor, but it's a moderate predictor. It might be usable. What might be most interesting, though, is to take the two good variables and put them in the same model and see whether or not you could get even a better prediction of landscape cost. So let's do that. For Excel to include more than one variable in the model, the two variables have to be next to each other. So I'm going to copy that one over so that those two predictors, they have to be adjacent columns. It's just a requirement for Excel. So now let's go do a regression. And now we want both of those together for all 3 years. And we want the output range to be underneath. Let's see, I'm going to put it underneath the bottom. I'm going to put it down cheer. Alright, got the labels clicked. They were, because I moved this, so it's, I needed to remove this. Okay, good to know. Labels output, okay. Now let's go see both in the model. All right, so R squared got much stronger. So two predictors was better than either one individually. Negative 0.06 means put 6 zeros in front of the 2 here. So that's really small, way below 0.05. And then both variables are below 0.05 in terms of their significance in the model. So you get an even better prediction, including both of those in the model of predicting landscaping costs. So that would be the recommendation for your client, is to use all 3 years and to use these two cost drivers to predict landscaping costs. So let me know if you have a question.